15 part A, we have a curve y equals x to the 3 minus x squared plus 2 all cubed that has a minimum, so that means dy by dx equals 0 when x equals a, and as it's a minimum we also need d2y by dx squared for a minimum has to be, so therefore this has got to be greater than 0. So this is going deep into this second derivative here. So cut a long story short, we should be trying to find the moments when this has a gradient of 0, and that would take us to our maxima and minima or other points of interest. And so we should start by setting up the chain rule. If we let t equal x to the 3 minus x squared plus 2 such that y equals t to the 3, we can differentiate y with respect to t to get 3t squared, and we can differentiate t with respect to x in order to get 3x squared minus 2x. And then we can pull these two together in order to get dy by dx, which will be equal to, let's go with, do this one first, 3x squared minus 2x, followed by this one, 3t squared. T, we'll substitute back in, was x to the 3 minus x2 plus 2. Put that back in there. So we end up with dy by dx equals 3x squared minus 2x, close brackets, and then 3 lots of x to the 3 minus x squared plus 2 all squared, and we need the gradient of the line to be equal to 0 for a maxima or a minima. So looking at this expression here, I'd like to focus in on this area and pull out a common factor of x, so I can write x 3x minus 2 close brackets 3 x to the 3 minus x squared plus 2 squared equals 0, and we're going to be able to produce a 0 over here just by looking at this edge on this end. So we've got a solution when x equals 2/3, and we've got also when x equals 0. But which of these is going to be our, I forget what we're looking for now, let's read the question, has a minimum. So which of these values is hopefully going to produce for us a positive second derivative number, which would show that we have a minimum. So I've got a fresh piece of paper. I'm going to slide all the way up to this point here. Bring this down. There we go. And just take this moment to do the second derivative of t with respect to x in order to get 6x minus 2. Do the second derivative of y with respect to t to just get 6t, and then combine these two to get the second derivative of y with respect to x, which would be, and I'll do this one first, 6x minus 2, and then this one, 6t. Remember that t is equal to x to the 3 minus x squared plus 2, and we can substitute that in. So we have d2y by dx squared equals 6x minus 2, close brackets, 6 x to the 3 minus x squared plus 2, close brackets. Sorry to be doing that off the screen there. So we have our two values of x from earlier. We have 2/3 and 0. So we need to inspect both of those using the second derivative. So I'll start with when x equals 0, comma, and then we're going to do a bit of a story. And then when x equals, what was it? 2/3, when x equals 2/3, comma. What does the second derivative come out as in these circumstances? d2y by dx squared. So putting in 0 here, we've got 0, 0, 0, 2 times 6 times minus 2, so that's going to give us minus 24. Therefore this is a maxima, not what we're looking for, so I'll put a cross there. And then I'll have to get my calculator out for this one. We've got 2/3, 2 divided by 3 equals, and I need to cube that to the power 3, subtract 2/3 squared equals plus 2 equals times by 6 equals times by, and here I've got 6 times 2 is 12, divided by 3 is 4, 4 minus 2 is 2, so all of that times by 2 equals, I've got 200 plus, more importantly, plus 200 over 9, therefore it is a minima, which is what we're looking for. And then if you need to find the corresponding y value, you would just input 2/3 into the original expression, which would be 2/3 cubed minus 2/3 squared plus 2, all cubed. But you don't need to do that for this question because it's just asking for the x value.